So I want to give a slightly unusual talk in the sense that it'll only partially be about my work and it'll be a little bit of a perspective maybe about the group, all of us. So let's see what you think and invite objections, of course. So I thought I'd start with just saying what mathematical consciousness science is, following a question yesterday, but also just in general. So this term has emerged now somehow, mathematical consciousness science. That's what some people here identify with. And if I'd had to give a definition, it would be this one: the application and study of mathematical methods in the scientific investigation of consciousness. So roughly speaking, if we compare with physics, in physics we have experimental physics, which also uses formal stuff, but then there's mathematical physics, whose business is to make this formal stuff more rigorous, like everything you ever know about quantum theory in terms of math comes from mathematical physics, von Neumann, these sort of things. But then we also have philosophy of physics, which is about trying to understand what it really means, or how we can understand or maybe even improve it conceptually. And so I think mathematical consciousness science is basically the same sort of thing to the scientific study of consciousness that mathematical physics is to experimental physics, with the only difference that there's not such a clear distinction in our case, I think, to philosophy of mind, because conceptual questions are really at the heart also of formal approaches in consciousness science. But that's not what the talk is about. The talk is about what I more or less like the future of mathematical consciousness science. And I think it's fair to say there's really important work happening here, but what we don't know is whether we are a bunch of boats which somehow found each other on the ocean and are going in the same direction for a little bit, or whether there's actually some land. So here's a boat. I'm sure we found boats, but is there actually some land? And if so, what's the land and what we're supposed to do? And I think that's the big question. And the talk is about sort of this nebula, which you see here. And I think the nebula is starting to lift at one little side of this all. And this is what I want to talk about in this talk. And I want to be very clear. The nebula is not lifting because of any individual work or something. It's lifting, first of all, because there's lots of work in a direction within the community, but then it's also lifting because outside of the community that identifies itself with this label, everyone is very much invited, by the way, there's also a lot of ideas which float around, and I think just the task is naturally within the definition that I just gave on the last slide. And so, therefore, that's what I'm talking about. So I think there is potentially, or maybe even early signs of a structural turn in consciousness science, and the talk is about like let's make that happen, and obviously I say what it is. So let's start. I mean, so words shape thoughts, and in the same manner I think descriptions, loosely understood, representations, if you like, shape consciousness science. And so far there's two major ingredients which we have to describe conscious experiences. And I'll be using the word conscious experience here more or less tantamount with phenomenal character. So I'm referring to what it is like for me to give that talk, for example. So on the one hand, we have language, you can read these things, being conscious, like the creature distinction, but also then maybe experiencing a particular quale or stimulus. On the one hand, here's an experiment by the Dehaene group where you can see these things. But then we also have simple formalizations, like often we use sort of binary classifications to either denote the being conscious versus not being consciousness distinction, or to denote whether a stimulus is perceived consciously or not. And we also have simple formalizations of conscious experience. On the side of conscious experience, for example, many people use the positive real numbers to model how conscious something is. And I think that's wonderful. And so it's wonderful in terms of where we got, and it's also great math that's happening. That's not a criticism of the math that we used to then formulate theories with these sorts of things or in experiments. But I think it's also clear that it's somehow not really appropriate for what it is like. And so therefore, I think in many different, I would say in virtually every single discipline that's involved in studying consciousness, the idea to use spaces has come up. And what we see here is like lots of more experimentally oriented proposals. That's just because they have nicer pictures. Sorry to all the philosophers. So the idea is to use mathematical spaces, and the mathematical space is just a mathematical structure, to somehow improve upon the descriptions which we have. And so that's what this talk is about. So I want to give you a little bit of intuition what the idea is here. Why is someone using a space or a mathematical structure more generally to describe or model or represent conscious experience? I'll then tell you a little bit about the structural turn, and I wanted to cover three things, but time will only allow me to cover the first thing. I'll tell you I'll say a few words about these. But the question is really like, I think, what are the promises of this of these structural methodologies, and I'll cover better theories. And then there's also promises for experiments and promises also, if you like, for the conceptualization. Philosophy of mind, maybe, but most of all, like what we all think about the problem in the first place. And then finally, I want to talk about a first step in trying to build this foundation together for these sorts of approaches, and that's the question, like, what is a mathematical structure of conscious experience, such as a quality space or a phenomenal space? Okay, so let's talk about these spaces. I have 3 slides, and each one of them is building up a little bit of intuition. Well, I'll give you a proposed answer at the very end of the talk, but this is really just to understand what's going on. So here we have wonderful Scilab spaces from psychophysics. So you can see these are spaces which represent colors to the standard observer. And let's just go through these examples. So they are all metric spaces. So that means there's a metric space has 2 so-called domains. It has the domain of points, you know, these are like little, if you like, the colors here, and it has real values, which are here supposed to be the distances, and in this case actually the experience distances between color. Then we have a function which takes these 2, that's just called the metric function. It takes 2 points and gives you a distance. And then we have axioms. So for example, one of the axioms is that the distance between a point and itself is supposed to be 0. So that's the first order of intuition I want to build up. And just as a note, as I said, so I'm going to be talking about mathematical spaces a lot. Mathematical spaces are examples of mathematical structures as understood in mathematical logic. There's not actually, to the best of my knowledge, a distinction. What's a structure? What's a space and not a what's a structure and not a space? So there's some sort of convention involved on this side, but we're very clear what this means. Okay, intuition version 2. Analogy. So that's sort of the answer I gave to Maya yesterday, and I thought I'd bring it up. So the intuition is somehow, in all of the proposals that are happening, that mathematical spaces provide a new and somehow better way to describe phenomenal character, to describe what it is like to be. And I'll bring that example up again. So who knows this other than Yosha? Yosha, you know Zork, right? You played Zork. Yeah, wonderful. So that's a computer game, actually, for those who don't know. And, you know, it goes like it's text-based. It tells you, you are standing in an open field west of a white house with a boarded front door. There's a small mailbox. I mean, it's as boring in my mind as it looks. It's like literature without the art. Yeah, it's literature without the art. And then you say something, you say open mailbox and so forth. And if you compare that with the days we have right now, like this is Red Hat Redemption 2, maybe 2 or 3 years ago, like you see a difference. What's the difference? The difference is math. The difference is just math. We have mathematical structure here to represent the tree. I chose it because there's also trees in this thing, I think, or maybe later, but anyway. So,
the math, right?
Say again?
The green is the math.
There's math in terms of colors. Yeah, okay, someone is trying to confuse me. Anyway, so the point is, so it's much more detailed and it's much more rich. And the difference is math. Processors, GPUs enable us to use that math, but the difference is math. So the analogy is that much like in these games, in this development of games, there's a promise of coping, there's a promise in these mathematical tools and methods to describe phenomenal character, of coping with the richness, the apparent richness and the details of phenomenal character. And then of course also just with structural features. You know, we can point at structural features with words, but if we just want to represent like 1 million of them, which is probably the case in this picture, we just need something better. Okay, intuition vow 3, I thought it's best to just distinguish the types of structure that float around in philosophy, experiment, and in some theories. This is more or less FY, but it helps you to understand what the thing is. So there's structure which is, what I would say, you could say that structure in conscious experiences, so you could also say off conscious experiences. The domains here are qualities or qualia or what, I mean, these are options. You could talk about parts. You could talk about instantiated phenomenal properties. That's the example here, right? Every single point here is basically a color quality or a color quale, depending on which terminology you propose. And the structure are then relations between these. A quality space has relations between qualities, or or maybe instantiated structural phenomenal properties. They give the structure of that space in mathematical terms. But then there's also proposals which say, these proposals there, they talk about whole experiences, like my whole experience right now, and maybe that's a point in the space. And then the structure is in between those experiences. So here's an example. This is this inner perspective picture from Ernst Mach, which IT always uses. So maybe you could have a space where the points of the space are sort of whole experiences. You know, there's a sunrise here which isn't there, and then there's a relation. This is just to give you some feeling. And then one thing I want to be very clear, and that's the first relation that my talk has to Paul's talk. So this is really like here the structure really only targets the phenomenal character. It does not target the relation between the phenomenal and the physical, or the relation between phenomenal and the stimulus. So in a sense, so I'm saying this not as a criticism or something, but that's something we could understand better, like how these sort of things relate to the ideas there. Okay, time is a bit short, more on that later. Okay, so a structural turn. So raise your hand if you think that's probably too loaded. Yeah, I mean, that's a little bit of, I mean, you're supposed to raise your hands now. But I just wanted, so I keep a list of all papers. I keep a list of all papers where structural things are used. And the ambition is not to have every paper, but to have at least one paper per research program. Because I can't check with all the many research programs. So here's the list. We're at 55. If you work on this, you will find your name in that list. If I do not know of your work, please let me know ASAP. And the requirement is at least one paper from your research program should be in that list. Yeah, can found themselves, wonderful. Okay, so let's talk about what impact is. So the message for the last slide is there's lots and lots of stuff happening. So what impact could it have? And for time reasons, I can really, time is going, am I talking too fast? I still have 18 minutes, that's very good. So first impact is, I think, better theories of consciousness. And better means larger explanatory scope and more predictive. And so if you look at contemporary theories of consciousness, that's not true of all of them, but of many of them, maybe the vast majority, they basically work with a binary distinction, like do you experience the stimulus or not? Do you, are you conscious at all or are you not conscious at all? And they only address part of phenomenal character, namely, like is this particular quail, which is elicited by this particular stimulus, part of phenomenal character or not? And so the green one, the first one, the binary distinction, has an implication that they're actually, like technically speaking, apologies to all those who feel insulted now, they're kind of easy to make, you know. Like just at ASSC, won't say names, but you know there were talks and people found some new experimental result and they bam, new theory. So Jonathan is the only person I know of, where is he? There on Earth, who really tries to keep track of them. So the current list is 38. Not sure if the ASSC one is in there yet, but so it's very easy to make them. You know, there's a lot of difficulty in experiments and intuition, and like how to do the framing, but the consciousness part is cheap. And so I think these structural approaches, as I said, I think they offer a new and better way of describing phenomenal character. So they, as I mentioned, they cope with richness and details and also structural phenomenal properties. So one immediate consequence is that they address phenomenal character more wholly, and by that I mean just more of it. And so they have a larger explanatory scope. They do not just try to address whether something enters phenomenal character, but they address phenomenal character as a whole, and then you might be able to derive what happens in the case of something entering phenomenal character. And the second thing is that, like, if you want to build a structural theory, you don't have, like in a non-structural contemporary theory, you just have to find any binary distinction and stick with it. In a structural theory, you have to find a whole space, and you have to sort of glue that whole space to the rest of the structure you're using from science. That's more points, but that's also more sets, and that's more constraints. And so it's much more difficult to do. And we have, to the best of my knowledge, so far, like before slide I think 10 or something, we have 2 theories which have entered the structural age. That's IIT and that's Jonathan's theory. I'm going to propose another example, which is not a new theory. It's just like we'll come to it. But so we only have 2. And then the next level, which I think Jonathan and IIT is working on, is sort of then you might even want to connect the structure you're proposing to structure that's motivated on independent grounds. So that's a whole nother difficulty. So it's much more hard to make these, and therefore, in my mind, that's an indication that they're much more predictive. We could ask me about that if you worry about this connection. Okay, so here's an example. As I said, so here's pointer again to Jonathan's theory. He gave a wonderful talk about it. So IIT is often viewed as having the example that it accounts it can account for phenomenal character, and none of the other theories can, people say. And that's true. So IIT outputs these things. That's the 4.0 picture of what's now called a phi structure. It used to be called a maximally reducible conceptual structure. And they have this axiom that the quality of the experience is identical to the phi structure of distinctions and relations. So the quality of experience, which is another word I think for phenomenal character, is this. And GNW doesn't account for phenomenal character. It doesn't give this, and therefore it's not as good a theory. That's why some people say we only have one theory of consciousness, and that's wrong. Yeah, and those are people working on a folding argument, which is not me. So that's where the statement comes from, yeah? And so what I want to do now, just in one slide, is show you how you can easily amend GNW to be as good as IIT, precisely as good as IIT, and that leaves open the question of how good IIT is. So how do you do that? So can we reproduce this sort of stuff for GNW? And I'll go through that a little bit quickly, or maybe I don't have to. Actually, I think my watch is 5 minutes too much. Okay, that explains a lot. So the thing is, so let's look at what's the actual phenomenal structure in IT. IT gives you a host of math. Part of it is auxiliary. You wouldn't have needed it. Part of it is about the internal, if you like, structure of qualities, and then part of it is really phenomenal structure. And I've written that. Sean and I are actually working on that, I should say now. We're writing it up. So there's a set of phenomenal distinctions. Those are like the qualities. Then they have a product on this sort of mathematical thing that phenomenal distinctions are. So these are like the corners. They have a norm-like function, which is small phi, and then they have relations between phenomenal distinctions. And these relations can have different RT. So how do we reproduce that for GNW? Well, let's just look at the picture, which we usually have. So the picture is often interpreted as the points are individual neurons, but they're actually neuronal assemblies, I think. You could not think that these are individual neurons. So every point here is a neuronal assembly. So a neuronal assembly has a state. The state of a neuronal assembly in this is just a map from the neurons to the real number. You give like one real number, usually between 0 and 1 for every neuron. That's good. And so these spaces, they're called LP spaces, which is a space of functions. Yeah, if you don't know it, don't worry. It's just a collection of functions. You have certain operations. Those LP, and so we can now, working with these LP spaces, we can build the exact same structure they have here. And as an intuition, we're going to use something that Stanislas Dehaene said as AC25. He talked about the content of consciousness, and he basically said that's the topology as a vector. That this defines conscious contents. So topology as a vector, the only thing you have are topological vector spaces. LP is the best example. Like I would say the prime example of a topological vector space. Yeah, that's because it's a vector space that also has a seminorm, as I'll say like in 20 seconds. So we have these LP spaces in there anyway. So which properties do they have? Well, LP spaces, they form a nice category. They have a nice monoidal product. Well, great. It's exactly the same thing that we need up there. We have it already. Just a formal structure. Okay, so they have these norm-like function. Oh, wonderful. LP space is the essential point about an LP space is a seminorm. So it's already there. We didn't have to add anything. If you say GNW, you're already saying these things. Yeah, it's a consequence of what you're saying. And then the only thing we have to add is we have to add relations. So how do we introduce relations between the LP spaces that sit at the various nodes of the workspace? Well, let's just say there's a relation between one node and another node, if and only if the thing is connected by some neuronal connection. If there's an axion or dendrite going from this node to that one, well, then we'll say these two nodes instantiated a two-ary relation, and we can do that for many different, like depending on how they're connected, we get n-ary relations. So that's a bit fast. I've written that up already in a preliminary fashion, and John and I are improving it. And let me know if you want the thing. It's actually like the New York, the tutorial in ASSC has the write-up already. Okay, so the message of that is, yes, we can reproduce this from GNW, and it's not the message is not that's the good idea. The message is literally just, look, why don't we start thinking in that direction? It will make GNW more interesting. It will make it more competitive with AIT, and hopefully it opens up a few new avenues for testing it. Okay. So then there's also the thing with better experiments and reconceptualization. I wanted to say a little bit about this, but unfortunately time is too short. I want to say something which I think is more important. I also just wanted to say intuitions. I don't have any concrete proposal, but there are a few very clear intuitions where you can see how this can impact consciousness science. So I'm just going to point you to this. I just uploaded this, I think, the day before yesterday or something. Here's the QR code. It's on Phil Archive. You can read it up. So these 3 comments are something I'm not talking about here, which I think people have to know if they engage in this research. But basically the extended introduction, which I made in an old section, contains this stuff. It's not much. Okay, so the upshot so far is structural turn is coming and we need your help. We can only build the foundation together. So let's go ahead and do the very first step in building that foundation. So the first step, I think, in creating a thorough foundation for this stuff is we have to ask, what is the structure of conscious experience? And by this, I do not mean to say what concretely is the structure, but I want to say, what does it mean to say that conscious experience has any specific structure? What do we mean by that statement? Or you could also say, what defines why conscious experience have a metric structure rather than something else? What does it mean? Is that just a repetition? Sorry, I was finishing very late anyway. So again, so we're not asking about the actual structure, but we're asking about what the first question here, what's the actual structure actually means. And so that's the meaning of the question, what is the structure of conscious experience? And so if we look at just what we do usually, we have terms like qualities, qualia, consciousness, whatnot, and we need either definitions or conventions to use these. And it's just the same with mathematical terms. And surprisingly, people tend to think that it's not the same, and you can just go ahead and make mathematical claims. So the difference is that in the case of mathematical structure, these definitions or conventions, they're actually methodologies. And by that word, I here mean collections of rules and procedures that tell you how you have to proceed, either in theory or in practice, to make a certain claim. And these methodologies are mostly not made explicit. People go ahead and discuss structural approaches without actually sort of referencing a topology. And that's the first major point I want to make here. It is not meaningful to use any mathematical term without saying, either explicitly or at least implicitly, which definition or convention, which methodology you have in mind to actually, that could render that true or not when it's applied to conscious experience. And there are two major historical precursors that I think have shaped largely what we do today. These are quality spaces as introduced by Austin Clarke. And in this 1993 book, he really takes his stuff from psychophysics. So Paul, I was thinking that maybe if we at least engage with this so far, then we implicitly might engage with psychophysics. But of course, there's the question of whether Austin Clarke did something wrong. And then there are quality spaces introduced by David Rosenthal. And for reasons which are given in the preprint which I just had, both just don't work. I mean, I don't have the time to explain this, but you cannot use them for what you want to use them for in consciousness science. For concrete problems, but also for abstract problems. They do not. If you agree to using them as a sufficient condition, I can do stuff which you're most certainly not happy with in terms of yeah. Let's just leave it at that. If you're interested, I'll give you the reference later. Okay. So for some reason, this is not.
It's going.
Oh, it's going. Okay, good. So what I'm saying, we had two methodologies, and Tim and I, no worries, everyone who saw it before, I'm not doing the example. There's a wonderful example. It's the only thing people usually remember about stars changing. I'm not doing that. So we had two methodologies. They carried us a long way, and so the research that Tim and I have been doing is trying to extend or trying to come up with what's missing in these proposals so as to get rid of these problems which you can easily identify. And so what I'm going to do in the last few minutes is just 2 or 3 minutes, is just give you the gist of it. What's the gist of how I think, and Tim, how we think that you should use mathematical terminology in consciousness science. And here's the intuition. The intuition is, and I'm going to use the word phenomenal space here because it's shorter. The mathematical structure is a phenomenal space if and only if there's a phenomenal property in phenomenal character that behaves exactly as the mathematical structure does under variations. We'll have a second slide where I go more deeply into that intuition. But this is the idea. And just to emphasize, I'm using phenomenal space here. That presupposes I chose the quantities are something like phenomenal properties or qualities, and it also made a choice about the structure. But this can be reformulated in a very general terminology, namely using just the terminology mathematical structure of conscious experience, which in our eyes is the most general. So don't worry about this, it's a terminological note. So let's talk about this. A mathematical structure of phenomenal space, if and only if there's a phenomenal property in phenomenal character that behaves exactly as the mathematical structure does under variation. I'm now going to explain this term. So it's copied up here if you want to read it again. So what's the situation? Well, the situation is we have mathematical language. Some people think, well, there's a mathematical realm. Roger thinks that. But like in a more conservative starting point, is math is just a language. It's like some people speak French, some English, some speak math. And we want to use that language in order to talk about consciousness. And on the other hand, there's the concretum of phenomenal character. It's the actual experience that you are having. And so we want to understand how to bring these things together. And one baseline correlation, which everyone saw before, is that we can just consider sets of, you could call them qualities or sets of qualia. It's your choice what you want. In the paper, we just call them aspects because you can choose what you want, and depending on that, you can then apply this. So we have a baseline correspondence. We already have a weak link to use mathy stuff for phenomenal character, right? I'm seeing a bunch of color qualities right now. And now let's follow this. So the idea is, okay, we need if and only if, and now we need a phenomenal property in phenomenal character, so let's take one. So that's a phenomenal property now. And here's a mathematical structure. And now the point is, they should behave in the same way under variations. So what's a variation? Well, a variation in this is a definition here, that's how we use the term, it's just a change of one conscious experience to another. That's a variation. Okay, so that's why, so we can change the set here, change the mathematical structure around, so the domains of the mathematical structure around, and we can use, just do anything to change conscious experiences, change of stimuli, introspection, whatnot. And the point now is, so variations, because this baseline correspondence, a change of conscious experience, I have some qualities, I change it, I have others, so it's literally just a mapping from a set of qualities to another set. And now the behave in exactly the same way really just means the following. On the mathematical side, I have variations that might preserve a structure or not. That's just, they might be a homomorphism or not. Yeah, that's just a well-defined concept in the realm of mathematical language. And on the side of consciousness, there's a concrete fact to the matter of whether I change this one phenomenal property I picked or not. Now the requirement, which is implicit in this intuition here, that's an intuition up here, is really just like whenever a variation changes a mathematical, whenever a variation preserves a mathematical structure, whenever it's a homomorphism, it's supposed to not change that phenomenal property, and vice versa. Yeah? So the idea is I have something in, so this whole slide just gives meaning to the statement that there's something in conscious experience, a phenomenal property, that behaves exactly as the mathematical structure does under variation. And that's the proposal. Yeah? So they need to be the same. And that's a methodology which actually extends the previous methodologies. The previous methodologies are still, you can't see that now. They're still in there as a necessary condition. But we've now added something to get rid of problems which you can show exist. And last slide. I hope, I'm pretty sure. So what I like about this proposal is really that it's compatible with all ways of investigating conscious experiences. There's a long history of David Rosenthal, for example, rejecting introspection, and you don't have to have that if you just go to a slightly more general notion of variation. You can do introspective approaches, you can do experimental approaches, and you can do theoretical approaches, and that's because the concept of variation is so simple that it's defined in all of these cases. You have identic variations, imaginary variations, in phenomenology, for example, stimulus variation in experiments, do intervention in experiments, and then you have some mathy stuff, just mathematical considerations of changes. Okay, and more on that, if you're interested in why the existing methodologies can't be used, is in this and the other paper I just showed. So this paper is a very abstract paper, so we consider just the abstract sort of condition that's there right now, and we show how that can work. The other comment which I just told you is really about like very concrete example what doesn't work with these methodologies we have. Okay, and that's it already from my side. So thanks very much for the attention. Yeah, I'll do. Yeah, okay, I was too quick. Yeah. I'll do the summary real quick. I'll do the summary because I really like it. It was a lot of stuff. So first point is mathematical structures are novel tools to describe, model, or represent conscious experiences. And novel doesn't mean chronologically novel, but novel as compared to what we do. They can be applied to theories of consciousness to make them better. And I think that there's a need of thorough foundational work that's in the ballpark of MCS. And I invite everyone to contribute to all of these questions, theories, experiments, and philosophy. And we looked at a first foundational work, and that's really how to understand and define the term mathematical structure of conscious experience. Thanks again. Oh, yeah. Yeah.